Hello, and we're live, Good morning, everyone. 10 a.m. Singapore, Hong Kong, 9 a.m. Phuket, Bangkok. My pleasure to kick off FIST 2020, FIST number 3, virtual FIST, the interim FIST in between the live FIST. And it's my pleasure to kick it off with my friends with the tropical shirts, John and Matt from XCO2. Who will be giving us a masterclass, the first masterclass on sustainable hotels and resorts. Now, this is not just your average sustainable hotels and resorts class, workshop, session, presentation. There will actually be tangible information you can use in your respective hotels and companies, generating a massive ROI on this session. So before taking it away, I want to thank our sponsors and remind everybody that there is an exhibit floor that is now open as well, where we have a dozen exhibitors, fabulous, fantastic exhibitors waiting to exhibit, waiting for the exhibitees, waiting for exhibit happens. So please feel free in between, or if you're taking a little bit of a break, go into the exhibit hall, visit our exhibitors. In the meantime, please welcome John and Matt. Please take it away and masterclass us on sustainable hotels.
I think we're live, John.
Yeah, it's gone. Our screen is up. Yeah, cool. Okay.
Yep.
So hi. So I'm John. I'm director from XCO2. It's quite dark where I am actually, because I'm actually in London. It's 3 a.m. here. I've managed to stay up all day, without taking any stimulants to do so. But I've managed to stay up until 3 a.m. for this exciting session, which I hope you will be tuned in for the entire session. And just like to say a very, very quick thanks to Eric and to all of the organizers at FIST. We're delighted to be back again. So please do sit back and enjoy our how-to guide for new and existing properties, which we hope you can take some good lessons from and apply to your new and existing upcoming projects, or just in general, just out of interest to learn. Excellent, Matt. So if you can drive the slides, that would be great.
Cool.
Okay, so just to give you a bit of insight into sort of where we're coming from, at XCO2, we provide, I guess, services under a few different subjects. The first being MEP. The main reason for this is that under MEP, I guess, is responsible for, in certain climates, up to 50–60% of the CO2 emissions. So it's very important in any project to deal with the MEP and the mechanical and electrical services within a building. Certification is another subject that we take responsibility for. The reason certification is quite important sometimes is it allows you to use a single metric or a single system to compare different properties, to see how different properties are doing, and test them under, I guess, a holistic set of subjects. So not just focusing on CO2 or energy, but looking at waste, water, ecology, diversity. We also focus on performance because, as I guess a lot of you guys know that are involved in operations, just because a design team spends a lot of money designing a building and handing over the keys, the energy use is actually in performance and in operations. So it's very important to go back and revisit properties and to look at ways that we can improve them further during their operations. And then the last stage or last component which we work on is master planning. So again, very applicable to larger resorts, where it's important to really think big and think about where those big pieces need to fit in, and look at ways that we can complement connectivity into adjacent sites and neighboring properties to make the best of environmental strategies. We have worked in over 30 countries globally, dealing in all sorts of climates. For this particular presentation, we're going to focus mostly on tropical climates. I think that's where most of the audience tends to focus their efforts and tends to work in. And again, that tends to be one of the most more challenging climates that we tend to work in. So the next is over to you, Matt, then. A little bit of interactivity for everybody. So it's important. Yeah, it's good to get your mobile devices out, because we've got a little bit of homework for you guys to do.
Indeed, guys. Yeah. So hopefully everyone is watching on like a laptop or on a computer, and so if you can take out your mobile phone, so you can see there's the QR code in the center of the screen there. And so that will take you to our online poll that we're going to do during the session here. So the question is, what do you think sums up a sustainable resort? So the results will be collated into a mind map, which we'll have a look at a little bit later. So just a few rules of convention. So try and make it just one word. So that means the computer can match it a bit easier. Again, keep it all lowercase so it's easier for the computer to match. And if you have 2 words, then you can do it twice. Anyway, so if you could do that, that would be cool. You can do it throughout the presentation. We'll check in a little bit on the results later on in the session. So while you're having a think, you can see the code up in the right-hand side there. So while you're having a think, for us, sustainability is a holistic approach to design and operation of hotels and resorts. And we're not just talking about like the hard figures, so the energy cost, carbon footprint, water consumption. It's also the intangibles. So what's the social impact of your property? How does it impact the local community? How do your guests feel? Did they learn something? Did they take something away? Did they change their behavior? So indeed, it's about idea sharing, and it's 100% what the essence of FIST is today. So how can we learn and teach each other, and how can we improve? And largely, like as owners and operators, you can choose whether you want to have a sustainable hotel, a sustainable resort. You know, by the way you invest in design and maintenance, and how you run the property, and how you train your staff, and indeed how you engage with your guests. So these 2 graphs here are just examples from the Cornell Sustainability Hotel Benchmarking database. And this is the electricity and water figures for a cohort of 5-star hotels in Jakarta. And so all these properties have the same location, the same climate, the same access to utilities, the same environment. They're all urban hotels, and they're all targeting the same market. So they all have similar levels of service, room size, so on and so forth. But as you can see, there's a huge difference between the bottom performing hotels, so the top 25%, how much energy they're using, for example, versus the bottom 25%. You know, and it's massive, and the same trend that we can see over on water. Like, I think the top performing hotels are spending 40% less energy and using 30% less water. And yet, this is crazy because all the hotels have the potential to perform at the same level. They're all servicing exactly the same sector in the same location. Like, if you were a hotel owner or an operator, I'm not sure how you'd feel knowing that your competitor down the road was spending half the amount of money on electricity that you were, or were getting all these awards or social accolades for actually reducing their impact. You know, you might want to do something about it. And so that's, as John was saying, is the sort of the idea of this masterclass. And certainly the starting point here is always understanding where your pain points are. How can you use data and information to make better decisions? So this is the consumption breakdown of a resort in Thailand that we did an audit on. And I've included it really just to show you like the sort of breakdown, the analysis that you should be doing to start getting the data to make decisions. And it's not just the hard stuff, the water and energy, carbon. You should also be coming through your staff responses, your guest feedback, so that you can figure out how you can improve, where your pain points are. So guys, just very, very quickly. So hopefully we'll do a quick check-in on what some of the answers have been for our Mentimeter quiz. So hopefully you've all taken your phones out. You can still do it now really, really quickly if you haven't yet. So let's have a quick look. Awesome. Oh, wow. A lot of people putting some numbers in. So we've got conservation, renewables is a, oh, hang on, is that? Yeah, that's showing up. Yeah, perfect. Circular economy, net zero, balance, excellent. All right, we're off to a great start there. So we'll see how that maybe develops over the rest of the presentation. Now, if I can just figure out how to go back to my original screen. And we're back, perfect, cool. So what are we going to talk about today, John?
So we've broken the content down into, well, 5 sections. 4 is the sort of learning bit. So the first section is the energy and renewables bit. Within this, we will just run through some of the more well-known technologies. We run through some of the details, some of the numbers, some of the expected figures that you might expect in terms of payback or return of investment. Then we'll move on to the water management and reuse section, something that's becoming increasingly more important globally, not just in tropical areas or not just on island sites. And then looking at passive design and low-tech solutions. So really the emphasis here in this section is more to do with design of the buildings, getting the design of the buildings right to reduce the energy demand in the first instance, and enhance comfort in the buildings, to reduce the amount of technology and renewables that you need then to become more sustainable. And then the fourth section, this is a demystification of sustainability certification. We think there's quite a mixed views in the industry on sustainability certification. So again, we're just going to run through the key headlines for some of the big sustainability certification systems, and explain really what the different routes for certification are. And then at the very end, then we'll run through our sort of top 3 questions asked by clients and design teams on our typical projects, and we'll open up the floor if there's any questions from anybody who wants to feed some questions into the chat, and we can try and pick up a couple at the end if we've got time. So looking at energy and renewables, the first technology which everybody's probably familiar with today is photovoltaics. Photovoltaics are still the #1 renewable technology for hotels and resorts. They're the #1 technology for guests. It's what guests want. It's what they expect to see if they're staying in an eco or sustainable resort. The system components that we look at for photovoltaic systems, typically you've got an array of panels. Those panels need to feed into an inverter. That inverter then usually converts the electricity into AC, so it can be used more readily within the buildings and within the developments. And then in certain locations, if possible, if you can sell electricity back to the grid or dump it to the local municipal grids, then there would be connection to that and a two-way meter to meter that energy as it goes to the grid. On the next slide, we're going to look at some of the details, I guess, some of the figures. And this is something that's very, very important to know, because it leads into this big challenge. Everybody talks about this term zero carbon, and they want to achieve zero carbon or carbon neutral for a sustainable or eco resort. But it actually has quite some challenges, especially on island sites, where on an island site generally tends to be smaller grids, smaller electricity grids, as opposed to in large land masses with neighboring countries on shared grid networks. And the challenge being this: if we look at the graph in the center of this diagram, or the center of this slide, you'll see the very light gray profile, and that's over a diurnal range, over a typical day, where you see the demand for electricity. So as you would expect, in the morning, people are getting up, potentially showering, switching on their AC, or cooling down their AC even further as the sun rises, and then go out for the day, spend the day outside by the pool or by the beach. And then in the evening time, again, the increased demand on the right-hand side, you can see in the light grey, where guests tend to have dinner, return to the room, and switch the AC back on. But the problem we have with this is that the demand doesn't follow the same pattern as when the electricity from solar panels is produced. So you see the blue crests in the center of this graph. You can see that typically that's what you would expect in terms of solar electricity production from photovoltaics. So the problem we have on an island resort is that if we install lots and lots of panels to try and achieve this zero carbon strategy, the problem is, what do you do in the middle of the day with the electricity when you cannot use it? When there's no demand on site, what do you do with that electricity? So the challenge you have is, as I said, in an ideal situation, if you can use the local grid and local infrastructure to export some of that electricity and then take it back when you need it, that would be excellent, but that doesn't always happen, especially on small island resorts. Or the other option then is to have on-site batteries where you can actually store the electricity as it's produced during the day to reuse it later in the day. But that, of course, becomes much more expensive. So just to look at some typical figures, we've broken this down into different options for delivering 15% of the demand, 30% of the demand, or 95% of the demand from photovoltaics. And looking at what is the investment required, and what is the payback required. So as you will see, if we want to make a 15% contribution, so meet 15% of our electricity demand from solar technology, typically we would expect that would pay back in between 3 to 4 years. Again, this is just looking at an example project in the Philippines. Looking at 30% to have 30% to meet 30% of the demand, you're at a point where meeting 30% of the demand, you will still need to store or export some of the electricity. So there's a greater infrastructure cost because you're spending money on some sort of storage system, such as batteries, to store the electricity on site. So the payback then increases. The payback actually rises up to, between 7 and 8 years. And then trying to, achieve this holy grail of carbon zero, or approaching carbon zero, by delivering 95% of the electrical use by the use of photovoltaic panels. More infrastructure is needed for batteries, which become quite expensive. So you can see it's not just a no-brainer. It's quite simple technology. It's been around for decades. It's improving all of the time. I think the most readily available panels are achieving efficiencies of between sort of 20–25% now. So it's making big leaps, and has been around for decades. But again, it's still not just an easy fix for projects. And then, of course, there are challenges in relation to how do we actually install the panels, and how do we implement them on an eco resort. Guests, they want solar panels, but at the same time, they don't necessarily always want to look at vast swathes of solar arrays. So looking at different options, the priority that we usually follow on our projects is applications to the back of house, staff accommodation, using rooftops and larger rooftops and larger buildings in the back of house first. Next priority then is looking at villas, front of house roofs, where it can be discreetly located or not seen by the guests. And then in other sites where there's no restriction on land or even water for floating arrays, that's where bigger opportunities can be achieved and deliver a greater proportion of your electrical demand on site through the use of photovoltaics. And then just looking at one case study under this particular technology, Son of Afushi in the Maldives. This is a project that we've worked on for quite some time now, and every few years we're back there to implement or expand on the existing strategy. So this is I guess the approach we talked about earlier on, where it's not just finished where you hand the keys over. You need to continually try and improve and enhance your project. So in this particular project, most of the PV is in the back of house, or back of house buildings were not readily accessible by the guests, but they can still go to visit as part of the experience of staying on an eco resort. Currently, the array there is up to 700 kilowatts, and per year it's saving 300,000 litres of diesel per year, which for a very remote island resort, which otherwise would have had to have diesel shipped to the resort for generators. It's a big environmental improvement, a big environmental enhancement. The solar contribution is approximately 30%. So again, we do need to have some method of storage on site, or we need some way of shedding the loads for when we produce or overproduce the electricity during the peak day. So that's one example. I'll hand it back to Matt now for the next topic, which is wind turbines.
Yes. So wind power is a technology that a lot of our clients and collaborators get very, very keen, very excited to explore, and with good reason, right? Like, we've had sort of 10 years of 15% growth in wind energy over the last decade. So what do we need to know about wind turbines? Well, the easiest place to start is that not all turbines are created equal, and by equal I mean equal in size. So the general rule is that you have sort of 3 basic sizes: large, medium, and small. So large ones, typically 1 megawatt or larger, they're on wind farms in remote locations or offshore. Medium or small, so you'll find these in industrial parks or sometimes in urban locations, and they're typically 100 to 500 kilowatts. And then sort of micro size, which is like building or residential size, so 5 to 50 kilowatts. And this is important because the key thing with wind turbine feasibility is access to wind, specifically the right type of wind. And so by that we mean 2 main factors. So what is the average annual wind speed, and what is the strength of the prevailing wind? So for example, for average wind speed, a good rule of thumb, which you can get from your data close to site or from your on-site weather darting system, is if you're looking at sort of 7 meters per second, then there's potential for that site to be a good candidate for wind energy. And wind speed is pretty important because the wind energy content varies with the cube of the speed. So if you double the average wind speed in your site from, say, 7 meters per second to 14, you don't just double the amount of energy you get out of your wind turbine, you get 8 times more energy. So even small shifts in the average wind speed can make a really big difference to your feasibility of wind turbines on site. And similarly, consistency of wind direction is really key. So the windrows diagram that we can see on the right-hand side here, so that's showing that we're getting a strong prevailing wind from the southwest, and this allows the designers to optimize the orientation, and it also removes the reason to have yaw drives in the turbine, which again, decreases maintenance, decreases cost. So again, a little bit like before, looking into a typical payback. So if you had a wind turbine and you had this sort of ROT of 7 meters per second, these are the types of paybacks that you would expect from the kit. And they're all doing pretty well, but as you can definitely see, the larger turbines are paying back in sort of 4 to 6 years, medium size, so 250 kilowatts in sort of 9 years, 9 to 10 years, and 15 kilowatts, so the small building mounted ones paying back in sort of, 10 to 13 years. And this is for a couple of reasons. So the larger units tend to be a lot more cost effective in terms of USD per kilowatt of installed power. It's also because the larger units tend to be more efficient and have better build quality. But the key thing really is that the higher the turbine, the better access that it has to high speed and consistent wind, which, as we saw on the graph before, is so key to getting the feasibility for this technology. So another key energy used on site is hot water. So how do you produce it and how do you distribute it? So broadly speaking, you can set up your system in 2 ways. You can have a centralized system where the heat generation equipment is located in the back of house, and hot water is distributed around the site through an underground pipe network. So because the equipment is centralized, it's typically a larger range of energy inputs that can go into the system. So we're from traditional fossil fuels or electrical input through to sort of more renewable or lower carbon, such as generator heat recovery or geothermal, for example. And opposite that, obviously, you couldn't go with a decentralized system. So that's where each building has its own generation and storage within the site. So and each building is independently done. It's a simpler system to install and manage, but you have fewer opportunities, I guess, for low carbon or renewable options. So for both new and existing properties, typically we're assessing these technologies here for centralized and decentralized. So generator heat recovery, so that's where you're on an island resort or you're not connected to the grid and you're capturing waste heat off the generator. So that's one. You can have heat pumps both in centralized and decentralized options, so it's an electrically driven system. You tend to get slightly higher efficiencies on a centralized system just because of the build of the equipment, but that needs to be balanced with the requirement for a network. Solar thermal, again, can be both centralized and decentralized. And there's always a balance here in terms of like the competing roof space for PVs, but also sort of integration with the architecture and with the landscape design. And then lastly, electrical immersion, which is the base technology, if you like. It's the least capital cost, but it's also the least efficient, so it has the highest operating cost. And it's the one that we compare a lot of the other technologies to. So as an example, this is a resort project that we worked on in the Maldives. So it's a little bit bigger than what you'd find typically in the Maldives. It's 120 Ps, 16,000 meters squared GFA. And you can see from the results, we've tested sort of 5 different technologies here. And they all perform pretty well when compared to obviously the least efficient one, this electric immersion system. So what we found is that a decentralized heat pump system was the most efficient system, and that's mainly because of the way the island was laid out. That the infrastructure costs of doing this were a little bit higher than what you would find on perhaps another resort. But all the other technologies also perform quite well. Probably the only other thing that's worth mentioning here is that the client didn't want us to look at a decentralized solar thermal option. And that's mainly because they wanted to maximize the amount of PV on the roof of the building. So yeah, we're used to dealing with, that's one of the things you need to consider, I guess, with this is how the systems are going to integrate with the resort as a whole. So I'll hand back over to John to talk about some sort of more emergent and site-specific stuff.
So now we're just going to run through some technologies that perhaps you might not have heard of before, or perhaps are not used as commonly as what we've covered already. Just to give a bit of flavor and a bit of variety to the presentation, and to maybe open up our views on what potentially is available to use within the marketplace. One of the first technologies we're going to look at is seawater cooling or saltwater air conditioning. So this technology works on the concept of basically taking cold water, which you tend to find at deeper depths within the ocean, which we then pump up to ground level, run through a heat exchanger, and then have a clean water network to run through all of the AC equipment. So effectively, this works best when we get down to maybe between 600 and 1,000 or 1,200 meters deep. So typically in locations that perhaps have large shelves or atolls in the ocean bed, where you can drop pipework down to very, very deep levels. And then, ideally what we're looking for is temperatures between 6 to 10 degrees. which would be, ideal temperatures for running through fan coil units or typical air conditioning systems within projects. And this is something, it's a very, it tends to be a very, very viable technology. But right now it hasn't really been used on that many hotels and resorts, perhaps less than 20 globally. One of the big challenges is getting the contractors, of course, because if it's a technology or system that's used not so commonly globally, there are, it's the challenge is finding the right contractor that can actually deliver this system and have it working properly. There are some projects where it has been used quite successfully, and I think the big benefit here is that it brings about huge savings. If you maybe recall the pie charts that Matt showed at the very start of the presentation, you could see from that the biggest energy user on typical island resorts in the tropics is air conditioning. And again, if you're getting all of your cooling effectively for free, with the exception of the cost of pumping the chilled water up from the depths of the ocean, everything else is effectively free or very low cost cooling from this system. Next, we're looking at ocean and wave power, and this is something that perhaps we're usually not so keen to look at, but it is a technology that's there. It is something that you hear about from time and time again, especially when you go to a lot of trade shows. There's a lot of emerging companies, new companies that are looking at ocean and wave power, but it has been around for quite a long time, and it still operates on the same mechanical principles. So it's not like wind turbines that have been around, have been refined, and obviously are very effective or cost effective as a mechanical system that produces electricity. These products tend to be a lot more difficult. With technology, with coding and electronic control, they are improving, but not at the rate as we would like to see, especially considering a lot of island resorts have access to water, have access to seawater, have access to change in tide levels and ocean currents. So this is something we'd like to see improve in the future, but I think right now it's there are very few products on the marketplace that are commercially available at a small scale. And again, a lot of the technologies are still in development phase, but something to watch out for the future. On the next slide, we've got 4 probably even further down the line technologies, but this is sort of cutting edge type products. The first being building integrated photovoltaics. So this is where the photovoltaics are actually built into the actual glass. So windows effectively could be used not just let through daylight and not just to let out views out of a guest room. They could also be designed to actually host photovoltaic panels. Generally, this tends to be very more commercially viable on a very large scale. So we are seeing this more in use in urban environments, but the cost is coming down all the time. So on a resort type scale, an island resort type scale where perhaps you're not going to high-rise territory, this is something I think we might see in the future when it becomes cost permitted. Then looking at biomass and algae facades, this can be used to generate energy. So this is actually using organisms, live organisms, to generate energy on a development. Again, it's something that's very much in its infancy. Biotechnology has really advanced over the course of the last 10 to 15 years, and I think this is something we are going to see a lot of in the future. The third one we have here is ocean thermal energy conversion. So this is where we take the temperature gradient. So earlier I spoke about deep sea water cooling, where we actually pump up deep sea water at a low temperature to provide direct cooling in buildings within a development. This technology actually works as a thermosiphon. So it works on the temperature difference between water at different depths in the ocean, and drives the water through to then generate electricity through a turbine. And again, very effectively, free energy. But this technology certainly is still in its infancy and requires very large infrastructure. So it's not going to be commercially economical for small projects for quite some time. But for very large master planning projects where you've got, I guess, master developers or else cooperative developers on adjacent sites on a large scale, this is something that we might see probably within the next, I think, 10 to 15 years. And again, ideal climate for this is in a location where you've got a very deep seabed, not too far from the shoreline. Graphene filtration is something that is, I guess, changing seawater desalination. Traditionally, we would use, reverse osmosis system with a dense membrane or filter system, where we would need a lot of pressure to push the water through to take out all of the particulates and take out all of the saline content from that. But graphene filtration systems now are becoming much more commonplace. They're becoming much more cost effective, even on a smaller scale. And whereby the system actually doesn't need to have such a dense filter to push the seawater through, and therefore you need less energy to actually push the seawater through to desalinate it and produce clean, potable water for development. One such case study that we quite like. It's not one of our projects, but it is a project that we do quite like because it does combine a lot of these very I guess I would consider to be future technologies. They're not necessarily established as commercially viable technologies just yet, but the brand in Tahiti has actually adopted quite a few of these technologies already to be, I guess, the trailblazing project for some of them. So I do think this is something that we will see a lot more of in the future and see some more exciting technologies emerge in the course of the next 10 to 15 years.
Good stuff. So we're now on to section 2 of our masterclass, water management. So potentially our most scarce and precious resource. Water management is an important component on operating and constructing a sustainable hotel. So depending on your location, you'll most likely be sourcing your water from these 4 options. So either from a local network, so a local municipality or the city close by, like a borehole, basically either on site or close to the property. Or if you're on a more remote side, you're going to be taking seawater and desalinating, a little bit like John was talking before. And then lastly, you're going to be potentially collecting rainwater and using it to store on site and to supplement the other 3 options that you have. So if you're fortunate to have all of these options, these are generally the considerations that you should be reviewing for both when you're constructing a new resort, but also when you're an existing hotel or property and you're looking to reassess your water supply management. So for the local network, it's really about your total water consumption. So figuring out the value of your CapEx, your standing charge, and your consumption for both your non-potable and potable supply. So what's your total value of water? That's the first thing you need to figure out to compare it to the others. Rainwater harvesting, you really need to have a clear plan of how you're going to reuse the rainwater on site. So what's it actually going to supplement from these other 3 suppliers? It's only ever really going to provide a proportion of your overall supply. So maybe 10% is a ambitious but realistic target when you consider annual variability and space requirements. Borehole, so it's quite common in a lot of resort locations, so Bali, Cebu, Phuket. Tertiary treatment is probably going to be required to bring the water up to like local regulations for bacteria content or for saline. And then lastly, if you're going to go for a seawater system, it's usually because you don't have a lot of these other options. You're going to run it through a reverse osmosis plant. This technology has the highest OPEX and CapEx. And it's, as I said, it's only really on places where there isn't an indigenous water supply. So now you know sort of some of the basic considerations and sort of how you want to link that to your uses. You can start moving towards developing like an on-site water cycle within your property. And that's kind of the key thing we wanted to talk about in this section is like a sustainable water cycle, like will keep the maximum amount of water within the site on a basis of a use, process, reuse, repeat kind of cycle. So step 1, if we start here on our water sources, so this is where water enters into the site. So from one of your 4 options, saltwater, bore water, grid, local supply, or rainwater. You then manage in step 2, below that, an efficient use, you then manage the total amount of water on site. So you're trying to reduce basically how much you're going to use. The third step then is taking that wastewater and reprocessing it on site using a particular technology, whether it be an MBR, MBBR, or SBR, or even a septic tank. And the idea from that then is that you can reuse that treated water within your property, either for non-potable uses. So for example, so for irrigation or for secondary cleaning, or for perhaps even creating on-site water storage centers like open lagoons. And then from that point, then from those lagoons, that water can be fed back into your water sources. So again, like we were talking before, is it's about creating a water cycle within. The more ownership you can take of the water cycle within your site, the more resilient and the more dependable your site is, your process is going to be. An example, right, is this master plan project that we're doing in Fuquoc, where you can see these large lagoons, which are in the center of the master plan, form what we call multimodal bits of infrastructure. So they're providing amenity space, managing stormwater, but also providing a source of water for the brackish reverse osmosis system. So as a very quick example, so this is a really interesting case study. It's a project that we worked on a neighboring parcel here in Carlisle. It's called South Farm. And it's a really good example of this water cycle being intrinsically designed into the property. So South Farm, like I said, located in Carlisle, and when complete, the lagoon system is going to provide irrigation, fish farms, stormwater management, and as amenity space for guests and residents. So a little bit of an intermission. So if you hadn't before, guys, it's an opportunity for you to grab your phone. Maybe you've thought of a new single word that you want to use just to describe a sustainable resort. So you can have another shot at the title here, and we'll check in with the results a little bit later. But we'll move on now to our third section. So the first two sections were really focused on energy and water, on what systems and technologies you could put in place. But as John mentioned at the start of at the opening, like, you know, what can you do to basically decrease energy usage architecturally through like passive design measures, and what low-tech solutions can you use to basically try to encourage your guests to do the right thing, but also interact with your sustainability story. So in terms of passive design, put simply, basically it's understanding the local architecture and the local vernacular, understanding what makes people feel comfortable, and then designing to basically mediate between the two of them. And to be honest, this approach to designing for your climate is nothing new. Traditionally, people have always used passive or sustainable design to make their buildings more comfortable. But the key difference today is that we can use computer modeling to optimize the design measures that we want to do, to test and basically see which is going to be the most effective. We can optimize the passive design. So as an example, basically what we would do is we would choose a number of different design elements that we want to check. So whether we would look at the external shading or the ventilation strategy, we might look at some specifics of the building fabric, like the glass specification. We'll then create this thermal model, and that'll allow us to basically simulate these design changes and see what has the biggest impact. And so the output really is we understand the energy and cost data produced by the model. So you can see from this graph that we've tested on this example, a range of different design measures, and we can see the decreasing energy consumption from each of these tasks, and also correspondingly, like the financial impact basically. And the key thing here is that like it allows the design team to make like value-based judgments on what they want to implement, whether they're looking at changing from single to double glazing, or whether they're looking at a particular type of external shading they want to do, or even things like how they're going to lay out the master plan at a very early stage. And that's the power of this analysis. And I guess, yeah, depending on whether you're doing an existing or a new property, your approach might just be a little bit different, but the process will essentially be the same. So on an existing property, you might be looking at retrofitting, retrofitting external shading to the building, or looking at retrofitting like a solar film. Yeah, you'll be a bit more focused with your approach. Whereas if you have a new hotel, you can take the scope back quite a bit earlier and start looking at building massing or form of the building in order to achieve better passive design performance. But yeah, so what are the low-tech solutions? Like, what are some simple and easy ways that you can have your guests take part in your sustainability journey, like as an operator, as an owner? I guess these are three examples that we've been working on recently on various projects. So the first one really is what we call natural rewards. So guests are given a reward for choosing to naturally ventilate their room, i.e. not using the AC. And the way you measure this is like, there's a small condensate meter, which is just housekeeping can check on a daily basis and see whether the aircon was used yesterday. And then if they haven't, then you could give them like a gift, whether it be a bit of fruit or a voucher to use the bath, for example. The second one, a view of the water. So typically having an understanding of how much water is being used helps people to be more conservative. So what you could have here is a clear tank, which is integrated into the bathroom or into the shower fitting. So guests can physically see the water coming through or how much they would have used compared to like their previous shower. So again, it's providing that immediate feedback so that guests can still have a long shower if they want, but they can make a decision to use less if they want. And then lastly, a sustainable follow-up. So after they've had their perfect stay at your property, they just receive an email, just a short thank you to letting them know how their stay either helped the local community or assisted in reducing waste or in some sort of energy conservation. So it's an idea that they feel like, the idea means that they can feel a connection between like their stay and your sustainability story. So again, trying to close that loop. I guess, this is just our fourth case study. So this is just a really good example of where thermal modeling has been used quite effectively in order to reduce the energy consumption on a project. So it's a Six Senses resort in mainland China. And so we did the thermal modeling and LEED certification for this project. So just through massing, fabric specification, shading, and ventilation design, we were able to reduce the cooling load by 47% and the heating peak load by 57%. So a really quite effective use of passive design. And like I said, this project was actually going for LEED certification, which is a big driver for us to do this analysis on the project. And it segues quite nicely to our last section for this masterclass, which is demystifying, sustainability certification. So what do you need to know about the why, the which, and the how for getting your resort certified? So typically, there's three main reasons which we find clients seem to opt for formal certification. So the first one might be that the government, it's a government or planning requirement in order to do those. So not uncommon for markets in Singapore, Japan, Australia. But I expect we'll see this type of requirement creeping into places that are developing quite fast, like Vietnam, for example, over the next couple of years. That's one reason. The second reason might be that the client wants a sustainable resort, and certification provides a framework basically for the team to work through. The framework, the structure, the targets. So it's quite a good management tool for clients to achieve a sustainable resort. And the third option is that maybe it's a requirement by the operator or by the owner's corporate social responsibility. So there's those sorts of drivers. Or it might be the client really wants an easy way to market and to demonstrate to potential guests that they have a sustainable destination. So those are the three. But what are the pathways? So how do you choose? Because there is, like, this isn't even all of them. There's so many options for different certifications. But broadly speaking, you can split them up into two groups. So on the left-hand side here in the yellow, we have schemes which are basically on, basically based around design and construction stages. So looking at how you can change the construction, the design of the building or the construction methodology in order to make it as efficient as possible. Over on the other side, you have certain schemes which are really focused on the operational performance. So measuring basically, energy, water, waste. It's more about the operation of the hotel. And then you have a whole bunch which sit in the middle of these two options here, which can provide both of them depending on what you want to achieve. So which one of them should you choose? So, I mean, broadly speaking, it depends what your drivers are. So if you want to impact the design of the hotel, and you also want to have a certification for when you open the hotel, then you should probably look at a design and construction scheme. But be aware, I guess, that because of the high level of engagement with the team and with the process, your consultancy fees will be measurable, and there's potentially going to be an uplift in your construction costs. If you're an existing hotel, or you can wait for an entire year to give you 1 year of utility data, then potentially an operational scheme is a better fit. And I guess it's usually it can be a more cost-effective route because the certification schemes generally that focus on operations are a little bit cheaper to administer and to deliver. So that concludes pretty much the teaching elements of our masterclass today. So before we, as John mentioned, before we get into a Q&A with Eric and hear some of your questions, we thought it would be interesting just to share the top 3 questions that we get asked by some clients, just to sort of get your questions rolling, so to speak. So the first one, I think, John, do you want to do this first one?
Yes. So the first one here, I mean, again, we were just we decided to include some of the typical questions that we are asked by clients, and the first one we put in here is, when in the design process do you need to complete the environmental modeling? So you will remember the slides that Matt went through where he showed you an example of a project where he built a 3D energy model and then assessed different design techniques for that design to make design decisions, things in relation to shading, fabric performance, etc. The thing is, it's never too late, but with these things, the the best chance of getting a greater return is to do it early. So in the very early stages really is when you have the best opportunity to make the greatest savings. But that's not to say even on an existing project you couldn't undertake some environmental design modeling and assess, you know, some more subtle changes that you could make to your existing building stock to improve them or enhance them. You know, whether it's a strategy to improve daylight or reduce solar gain to improve comfort and reduce the cooling demand. You know, it's never too late to do that. But certainly, the earlier these things are considered and undertaken, the better chance you have of getting a better return of investment.
Indeed. So the next one we typically get asked is a zero carbon resort even possible? And the short answer is yes. And so there's two different pathways that you could go down to. You either need to have the appetite to invest in the systems that are required for some of the stuff that John was talking about earlier in the presentation. So the significant investment to get to 95, 90, 100% renewable energy. So that's one way. The other way you can go is you can decarbonize your concept. So again, when we looked at that slide earlier, talking about like where the energy breakup of the project was. So if, for example, you shifted your resort's focus to being a naturally ventilated or ceiling fan, based resort, then you could rapidly decarbonize or de-energize the requirements for your resort, and that could make it much easier for you to achieve a zero carbon project. So I guess, yeah, like we're saying, it is possible, but you need to choose, I guess, which pathway or a combination maybe that you want to do to achieve that. And then lastly, this is a bit of an unusual one, to be honest, which, gets asked more than I thought it would. John, I mean, this is one I think that you've got a bit more experience of than me.
Yeah, so this is something we get asked a lot. When we're looking at strategies for dealing with wastewater management, is the sewage treatment plant going to smell? A properly designed sewage treatment plant shouldn't really smell. Obviously, if you stand right up beside it and you go close, then yes, it's going to smell and have some odors. But a properly designed system should not smell from a distance. But certainly considerations should be made to put it on the leeward side of the site, away from direct guest access and where it cannot be seen. But the key thing is that it's properly designed in the first instance, and then it shouldn't really smell at a distance where guests would be attending. But it is a question that keeps coming up. It comes up quite a lot of projects. But it's not something necessarily to be scared away from. But something just needs to be thought through and designed properly. There's a couple of questions actually just in the chat on the session, from the stage chat from the session. We've had a couple of questions on the deep sea water cooling. One is in relation to the OPEX for pumping the seawater from depths, and also from the same person asking about the heat being rejected back into the ocean. And yes, certainly both of those are considerations, but it's very, very site dependent. The ideal scenario is having effectively a cliff edge on the seabed. The deeper the water gets, as close to the shore as possible, reduces the depth that you have to actually run the pipe to and the distance you have to run the pipe to, and then it becomes much more cost effective. So if you're on an island and the seabed falls away really, really deeply, but that doesn't happen for 2-3 kilometers offshore, then it's not going to be as cost effective as it would be on a site that has 500 or 600 meters out to sea before the seabed drops down. So all of these things need to be calculated and tested and designed in order to determine whether they're cost effective, rather than making blind decisions. So it's certainly something that is very, very site specific, and something that needs to be, I guess, assessed at very, very early stage, because the procurement for a system like that can take quite some time. I think that was really the key one. Yeah,
I was having just a quick look through. I think there's Eric making a little gibbet about like facial hair and Hawaiian shirt connection. But otherwise, yeah, that seems to be most of the specific questions I could see.
Okay. Yeah, a couple of things here. I think there's a couple of questions. So on the OPEX, so the issue is environmental impacts of seawater cooling, about the input and the output. I mean, we've heard this on the desal with the brine, that kind of thing. So what are the environmental impacts? I think, is there any consideration that you can comment on there?
Yes, so I think the question is in relation to dumping heat back into the ocean. So really, you know, if we're getting water up at 6 to 10 degrees, effectively we're going to reject that back down into the sea at 16, 18 degrees. But you know, you have to understand that it's you know, from a development, we're dissipating that water into, you know, a huge ocean. And there's ways that you can overcome that. Of course, you don't want to create sort of affect you know, the ecosystem in a very localized situation on the seabed. So you know, if it is a very large site, you know, there's the opportunity to dissipate that heat more evenly across a larger area on the seabed. There's also the opportunity to dissipate that heat not deep down, but actually at a high level where the water temperature is actually much higher. So in a tropical climate, even though we're taking water at 6 degrees from deep down, on the shallower parts around the islands, there's opportunity to send back the warmer water and actually not have any. We're not actually dumping heat back to the ocean because we're putting it back in the ocean where it's the same temperature as the water that we're actually rejecting back. We're not adding anything to the water. It's the same seawater that we bring up that we send back. So again, all of this is something that needs to be considered. But generally speaking, in a tropical scenario, it's not really a problem because typically, you know, the water we're dumping back is 16, 18 degrees, and in the shallow waters, the water could be, you know, 20, 25 degrees. So there's no net heat gain back to the ocean.
Very good. Thank you. All right. Well, actually, we'll talk one last, and you touched on this, is there a carbon neutral hotel possible? The question, a lot of these island resorts is the hotel itself can be 100% renewable, maybe. But what about the impact of travel getting there? What about the impact of the products and services, the food, and so forth? Now, is that something in your purview? And if so, is there a relation between the carbon emissions in the operation of the hotel versus the travelers, and is there any relation to that you've considered, or are we really just focusing on the specifics of the building right now, and we leave that for a different discussion later on in the day?
Yeah, it's it's not part of this masterclass. Correct, it's not part of this masterclass because this masterclass we're trying to focus mainly on design and operations. But that is something we do consider for a lot of our clients. So some of our clients are, you know, they're very keen to just focus on the buildings, the impact of the buildings on the environment. And then others actually, they want the entire resort, as in terms of, you know, going back as far as guests booking their tickets, getting on in taxis, flights, getting, you know, door to door effectively, and what systems are available to them to offset their carbon for that. It's quite difficult for, say, an island resort on site to offset all of that because you know, you'll understand the limitations you have on site in relation to solar or the easy win technologies. But we do engage with our clients to advise them on how to offset the I guess the tertiary emissions that are not directly related to the site itself, just related to actually how people get to and from site, and not just people. How, you know, the emissions of goods being delivered and waste being taken away from the site is also something that we would often consider, but it wasn't intended to be part of this masterclass.
All right, Matt, any follow up on that?
No. I think John's covered it all. I mean, I think it's a very good point. Like, you know, the industry as a whole needs to consider what it's going to do sustainability wise, like not only for when you get to the resort, but how you arrive. So maybe, you know, an option basically for hotels would be to offer like carbon offsetting depending on where the guest came, and that might be something they could do on site or something that they could sort of engage with a third party to do. I think that might be something that's quite interesting to the market. Like, you know, you could have a full zero carbon stay from when you leave your door all the way to when you go to the resort and come back. That would be quite cool.
Very good. Very good. All right. Any final words, John and Matt? And by the way, John, that was a fantastic answer to these Q&A at 4 in the morning, where you're still up and popping, right?
Yeah. So I might just actually have a beer now, just to kind of wind down and make sure I can sleep, because I actually do need to get up for work in 3.5 hours time. So yeah, I'll try and wind down quickly and get to bed quickly. But I'll be back online later. I'll be back for the afternoon for you guys. That's
what we call a true sustainability champion. Always a pleasure. I think just to wrap up there, the interesting discussion, sustainability is cross-cutting by definition. There are so many interrelated aspects, trade-offs and things. And what we've been trying to do here in FIST is advance it to the point where we have more specialization and more discussion that really gets to the point and brings education awareness on specific topics. I think that's what we need more of. And so I'd like to thank you, John and Matt, for your insight here, your masterclass. It was a masterclass, and we have it on recording. We look forward to distributing this and hopefully spreading the word again. Very helpful, very insightful. Thank you very much. So now, John, hope to enjoy your beer, and Matt probably shouldn't be enjoying your beer. It's too early for.
Let's have some coffee. Yeah.
There you go.
Okay, thank you, Eric. Thank you, everybody, for joining. Thank you, and yeah, we'll see you all soon. Hopefully see you in the flesh next year.
All right.
Cheers, all. Thank you.
Bye bye.